All right, so your introduction for 5.4, we're going to cover three major topics. One is going to be, what does your graph do when it hits the x-axis? It has two options. It can either bounce off or reflect. So reflect is the same thing. That says bounce off or reflect. It could also cross. Okay, so here's what that means. If you're looking at a parabola is going to come down and bounce off at the x-intercept. But if you're looking at a cubic function, it's going to cross through at the x-intercept. Okay, so this one bounces off and this one crosses through. So those are your two options when you are looking at the behavior of the intercepts. Another one that we're going to use is conjugate roots theorem, which sounds very scary, but here's what you got. If I know that x plus 2i is a factor, then I immediately know something else. X minus 2i is also a factor. So everything's the same. One is a plus and one is a minus. And this comes off of the quadratic formula and that kind of stuff. If you remember, whenever you take the square root, you always get a plus and a minus. Okay, so if I give you one of these, you immediately know, change the sign in the middle. Okay, so right along that line is, if I tell you that negative 5i is a solution, you immediately know that positive 5i is a solution. So I may give you one, but in reality, you know two because you just changed the signs. The last thing that we're going to look at is going to be multiplicity, and that just means certain answers can occur more than one time. So think about it this way. If I break down 100 in arithmetic, that's going to be 10 times 10, which is 2 times 5, which is 2 times 5. So 2 has multiplicity because it appears more than once. 5 has multiplicity because it appears more than once. So just like you can have things appear more than once as factors in arithmetic, the exact same thing can happen when you're dealing with factors in algebra. So just to give you an idea, I'm just going to start with this one. I made it up a while ago. So I know I'm going to end up finding three answers. Okay, because my exponent is a 3. Side note, that's called the fundamental theorem of algebra. Okay, the degree of your polynomial is how many solutions you're going to find. So because I made this up, instead of us going through all of the mess, I'm just going to tell you we're going to pull out a negative 3. I made it up so I know it works. All right, so I have a 1, a 5, a 7, and a 3. And underline that. And side note, if you will notice, you got a positive, 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 which means there are no sign changes when you are working from left to right. So Descartes' rule of signs would tell you that there are no positive answers because there was no sign change. All right, so using synthetic division, negative 3 times 1 is negative 3. That gives me a 2. Negative 3 times 2 is negative 6. That gives me a 1. Negative 3 times 1 is negative 3. And that gives me a 0. So my solutions so far is, of the 3 that I'm looking for, I found one, and he's a negative 3. So remember, this is an x to the third row, which makes this an x squared. I got a 0 at the end, so fill it in. So x squared plus 2x plus 1, and now this thing is factorable. So I need two numbers that multiply to 1 and add up to 2. So that's going to be an x plus 1 times an x plus 1, and that gives me 0. Well, then what's this solution? It's negative 1. What's this solution? It is also negative 1. And so for my solutions, I need 3 of them. I got a negative 3, I got a negative 1, and I've got another negative 1. That's multiplicity. So how could I write this in factored form? If negative 3 is a solution, then x plus 3 was the factor, because remember, you would change the sign to pull it out. So if x plus 3 was the factor, the solution would be negative 3. So when I take it out of parentheses, I change the sign. Well, if I put it back in parentheses, I change the sign. Okay, so negative 3 is the solution, but x plus 3 is the factor, which means I have which you have it right here. -1 is the solution, so x plus 1 is the factor. -1 is the solution, so x plus 1 is the factor. But math people are lazy, so we don't want to write x plus 1 twice. What I can do is write that as x plus 3, x plus 1 squared. So now you see I've got multiplicity. Just like up here, I could have written that as a 2 squared and a 5 squared. Now I have this thing occurring twice, so he's an x plus 1 squared. So that is multiplicity. So when we're finding solutions in section 5.4, the only difference is if I find something that works, I'm going to try it again real quick just to see if it's hiding in there again. It may not, it might. So I don't know. But when we try and find solutions, that is going to be our strategy, is diving in. Now, here's a way, hang on, oh, this is good. All right, so now I'm going to use this little example. So what did we find out a while ago? This up here is in polynomial form, okay? And I set it equal to 0 so that I could find the solutions, or where it hits the x-axis. This down here is the exact same thing. It's just in factored form. Okay, so if this is in factored form, I can tell a lot about the behavior at my intercepts, which is up here. All right, so the behavior at my intercepts, remember I got two options. So one of them is going to be to bounce off or reflect. So here's the fun part. What is your function for a parabola? He's an x squared. So if it's even, it will reflect. Okay. What is your polynomial for a cubic? He's an x to the third. If it is odd, it will cross. So ODD, OSS. Now, Hawks isn't going to ask you about reflecting or bouncing. Hawks is only going to ask you about if it crosses or not. Okay, so you only have to worry about if it's an odd exponent, it's going to cross. Okay, so come back down here. What is the exponent on your x plus 3? He's a 1. He will cross the axis. He'll slice through it at -3. What is your exponent on x plus 1? It's a 2, which means he would reflect off. Okay, but you would have multiplicity of 2. So because this thing behaves as though it's a parabola, if you ignore this part, he's a parabola, he would come and bounce off. If you look at this part, he's a line, so he would slice through. So odd exponents will cross, even exponents will reflect off. So now we're going to go in, I'm going to kill this video, and we're going to go in and start doing some examples.